Hello friends, welcome to my channel. Let's have a look at problem 98, validate binary search tree. So here we revisit this problem after Leetcode 333. So for interested audience, so please check out the video for Leetcode 333 and a previous video for Leetcode 98. So here the purpose of this video is to emphasize the connection of binary search tree with in-order traversal and practice the in-order traversal algorithm. So here I'm going to put more emphasis on the iterative format of the in-order traversal algorithm. So again, in this video, I'm going to write with certain redundancy for the ease of understanding. First, let's look at the statement. So the problem requires us to judge if given a root of a binary tree, if it's a valid binary search tree. So a binary search tree is a binary tree which fulfills the binary search property recursively. In other words, the tree itself and all its subtrees. So here are several examples. Let's look at example 1. So this is a binary search tree because the root value is 2 and the left subtree is a single node tree with a value 1 which is strictly less than 2. So similarly for the right subtree, it's also a single node tree with a value larger than 2. So this returns true. And in the second example, so the return is false. So if we examine the root 5, so the left subtree is 1, a single node. This is okay. And then if we look at the right subtree, so they have a root value 4, right? 4 is strictly less than 5. So overall, this tree is not a binary search tree. However, if you look at one piece, let's see, look at the right subtree rooted at 4. So this is a binary search tree because 3 is less than 4 and 6 is larger than 4. Or if we look at one piece, let's see, 5 and 1. So we cut the right subtree. Then 5, 1 is also a valid binary search tree, right? So with that said, so let's look at the constraints. So the number of nodes in the tree is in the range 1 up to 10 to the power 4. And this is the node value, which is a 32-bit integer, right? So with that said, let's look at a solution format we're going to present. So here the point is that, so due to the binary search property, if we do an in-order traversal of the binary tree, so in other words, we first visit the left subtree and then visit the node and then visit the right subtree recursively, then the resulted list will be in strictly increasing order. So the point is that given a list which is in-order traversal of a binary tree, if the list is strictly increasing, then it tells us that the corresponding binary search tree, the binary tree is a binary search tree. So with that noticed, let's look at the code. So here, actually, the coding is very straightforward. So we can do binary in-order traversal, and then we check monotonicity. So for doing the in-order traversal, there are two formats. We can use recursion, which is trivial, and also we can use iterative format. Here I'm going to present both just for completeness, and then after that we can do check of monotonicity. Let's first write a in-order traversal. So here, if we use recursion, so the in-order traversal is actually very straightforward. Let's first do this. So in order. So put the argument is a root value. Then first I'm going to check if not root. So this is an edge case or stop condition. So we're going to return empty list. Otherwise, we're going to return the in-order traversal of root left, the left subtree, plus the root value, and then plus in-order traversal of the root right. So this way, actually, we here we write with return, so it's going to return the list corresponding to the node value. So let's first finish the problem logic giving a solution format, and then we provide another in-order traversal format in iterative fashion. So let's first look at the check of monotonicity. So we hope that the resulted array to be strictly increasing. So I'm going to name a variable, let's see, in order root. So then we check the monotonicity. So let's call it n is length of array, and then we can check. So for I in range 1 to m, so we want if array I is strictly larger than array I minus 1, right? So if this guy is the latter one is not strictly larger than the previous one, let's say I minus 1, then we need to return false, right? So after the for loop, if nothing has returned, so we're going to return true. So this is the logic. If we are content with ourselves about this version of in-order traversal, so that's it. So let's do a check. Yeah, it passes the first example. Now let's look at generic case. It passes all the generic case. So now with the first version of in-order traversal done, let me write the second version. Again, I'm writing in another version of in-order traversal. So here we're going to use iterative format. So let me write maybe here, use another method. Let's see, in order. So I'm going to write as a method. So we're going to have a root. So here I'm going to write like this. So what we're going to do is like this. So we're going to first set the node to be root, and then we're going to initialize a stack. So this is standard actually. So the result is going to hold the final output or result. So here the check condition is while stack and not add, or node is not null. So in this case, so we're going to look at the very left, right? We want to push to the very left. So while node is not null. So what we're going to do is going to stack append node, and then we are going to put node to the node left, right? So once we exit the while loop, so actually we gradually added all the left branches or left roots as far to the left as possible. And then after we exit the while loop, then we do stack pop. So this way we first look at the very left node. So let's see. We're going to say node equals stack pop, right? So once we pop this node, we're going to append to the result. So that's a node value, right? And then after this, we're going to look at the right? So we have look at the very left inner node. So let's see, node right. So this way, after this while loop, so what we have is that as we exit the while loop, we finish the traversal of the tree. So we're going to return the result, and then we can actually comment out this one. Let's use this one. Let's use v2, right? v2, and then what we're going to do is that we do a self call here in order v2, right? So this part is the same, but we didn't use this one. So this is let's do a check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the cases. So with that said, I guess that's about it for this problem. So here, as we mentioned, the purpose of this video is to emphasize the connection of binary search property and the in-order traversal of binary tree. And we actually practice the in-order traversal in both recursive and iterative formats, but we emphasize the iterative formats. So with that said, I guess that's about it for this video. Thank you.